Alrighty, how are we all going? Should we make a start, Nima? I think we've got most people in here.
Yeah. Yes, you can. We can start.
Awesome. Well, thanks. Good morning and good welcome. I think it's morning over where you guys are. It's late afternoon here. It's about 4 p.m. So thanks for joining me. My name is Yuval. I'll talk to you today about data wrangling in R, along with Praise and Christina, who are my helpers for today. And acknowledging also the past slides that were made by Gloria, Janice, and Juniper last year. So, just to very quickly introduce myself, as I said, my name is Yuval. I'm a PhD candidate here at the Kids Research Institute Australia. I am co-supervised by MAP as well as Melissa Penny's team. If you've happened to met her, my current project is on estimating the receptive risk for malaria transmission. So in the absence of interventions or if interventions were rolled back, what is the potential for transmission that we might experience in sub-Saharan Africa? I'll throw over to Praise and Christina to introduce themselves as well, if that's okay.
Thank you, Yuval. Good morning, everyone. I hope you can hear me.
Mm-hmm.
As introduced, I'm Praise Michael. I work with the Ifakara Health Institute, based in Dar es Salaam. I work with the data science and mathematical modeling for decision-making project. Thank you.
Thanks, Praise.
Yeah, thank you, everyone. Good morning. And I hope you've already met me, Christina and Jan. Thank you very much.
Thanks, Christina. Great. And we have David as well. Perfect. So in terms of the learning so far you would have learned about things like good practices for data management, particularly using Excel. Nima took us through an introduction to R, and then there were also sessions around malaria epidemiology and foundational statistics in public health. So you developed a bit of a baseline knowledge for a lot of these different things that you might want to use as malaria researchers and malaria modelers. So what happens now if your colleague were to come up to you, tap you on the shoulder, give you a data set and ask, what is the number of confirmed cases in April in under 5-year-olds for every admin one in this data set? Well, hopefully we can start turning to R and doing some data wrangling. So before I get into that, and that is sort of the preamble for the workshop, I hope that everyone has completed the pre-workshop survey results. Are you please able to react um, with a thumbs up or with a tick mark if you have, and if not, please just spend a couple of minutes doing that now. Oh, thanks, Victoire. Anyone else that has completed it? I think I've only seen Victoire's reaction. Thanks, Gerson and Gil and Sylviane.
I see we have 6 responses.
Are we up to 6 now? Great.
Yeah.
I might just give another minute or two if there's anyone here that hasn't done it yet. Otherwise, we'll carry on. Alrighty. Oop. So, before I kind of get stuck into data wrangling, I wanted to really make sure I addressed AI and what some of the appropriate use cases and inappropriate use cases are for AI. Because we've all probably know we've all played with ChatGPT or various other models, and we can see how great of a tool it is, and it can be really handy in terms of helping us learn new concepts, code quicker, and be more efficient. But it does come with its own risks. So it often doesn't know or understand the context that you're operating in, which is really important as public health professionals. It may train on your conversation, so you should never upload or give access to private data or private information, or things that it might be sort of intellectually protected. And it can often make mistakes. And I have one great example of this here. So this is a real question I asked ChatGPT as recently as last week. So on the sort of newest models available, I asked if I wanted to wash my car and the car wash is 100 meters away from me, should I walk or should I drive? Now, obviously, if we stopped and, th and thought about it, if I want to wash my car, I have to take my car with me. I have to drive. ChatGPT very confidently told me that I should walk. It said that at 100 meters, walking is a lot faster than driving, so you should just walk. And then it hadn't logically thought about the problem that my car would be left 100 meters away from the car wash shop and far behind. Um, and this is quite emblematic of how ChatGPT operates. So ChatGPT and most other similar AI models are pattern finders. You give them a bunch of data and they try to find a pattern in it. They don't look for logic behind everything. So yeah, they look for patterns in language to predict the most likely response rather than enforce the logic. So we really need to take care with them. We make decisions that impact human lives, especially when you do modeling that is things like subnational tailoring, where you might decide which interventions go where. So we need to have a human that is ultimately accountable for the decisions that we make. We can't just rely blindly on the AI. So just a word of caution. Now, for this, I wanted to use Mentimeter to hopefully spark a bit of a discussion on whether the following AI prompts are appropriate or not. So please scan that code, and that should jump you onto Mentimeter. You can also scan it here, or you can enter the code. So I'll give you guys a sec to do that, and then we can have a bit of a discussion on each of them. So if you don't have your phone, you can go to menti.com and enter this code. Otherwise, you can use your phone to scan that QR code.
Looks like we can't see the QR code.
Is it not showing up? I think there are some others with the QR code available. Maybe try typing this number in 49296944 into menti.com. I can pop that number in the chat as well. Awesome, starting to get some responses. Great, we'll wait for one or two more responses and then I can start chatting through them as others are finishing. All right, maybe I'll get started there just as others are finishing. So, in terms of the first statement, what does the select function in the data apply package do? I would say that that's quite a good use case of AI. AI has access to all the documentation for coding languages and things like that, and it can really explain it well and often give you different examples to what might just be in the documentation. Obviously, for complete posterity and for being completely sure, you may also want to go ahead and double check the documents and the documentation of the data apply package, but this is generally something that AI does quite well, especially for a function which is in a very commonly used package, which is the data apply package in R. So that is one where this is a completely fine use case of AI. The second one, here is some malaria case data. Tell me the number of cases. I'd say most of you guys are on the spot there. That is not an appropriate use case of AI. We would be uploading data, which even if that data was anonymized, would still be sensitive health data. There would be a lot of sensitivities, and it might even be illegal depending on the state or territory that you're in to share that data external to your organization. So doing that would definitely be problematic. Here is a list of people's email addresses. Can you write an email to all of them? That is also one which is not going to be appropriate because there you're uploading private information and private data, right? So I, for example, might not want my email to be exposed to AI and also have my name or some things like that attached to it, which might come from that. So you shouldn't upload other people's private information onto the AI either. Helping you understand the bug or error in your code, yeah, that's also generally a pretty good use case of AI. You can paste the error that you get from it, and again, because it's been trained on all the documentation, it can really help you unpack what might be going wrong in your code. You can also upload the bit of code that caused the error, again, as long as nothing private or sensitive is exposed in terms of data. Now, the last one, this is a great distribution where everyone has answered right along the spectrum. And I would say that's great because it really does depend. So finding a citation that says there are 8 million malaria cases in Tanzania annually. AI can do that, but that is one of the prime examples where it hallucinates. So asking an AI to give you a citation is a fine use case as long as you click the link and go and read that citation yourself and find where exactly it says that there are 8 million malaria cases in Tanzania or whatever else it might be that you want to research. I've had it before where I've been brainstorming some ideas and I've asked it to give me a couple of citations on different modeling topics, and it can completely hallucinate papers. It's invented authors that don't exist or titles that don't exist, but I've also had it actually provide me links that have then led on to insightful papers and useful papers. So you can use it as a starting point, but I would never take the citation that it gave me and plug that into my paper, my report, whatever it was that I was working on. I would always follow the link and go and see if I can actually find this citation or if it hallucinated that. Awesome. That's the first little Menti exercise. So we'll get back to the main slides. Does anyone have anything they wanted to add to any of this from their own experience or anything like that? Happy for this to be a collaborative open session. All right, great. So I'll first go through some of the good practices when we code, just to help us make sure that our code is easier to read and reproducible. So the first good practice tip when we code is to make sure that every script and every piece of code that we write has a title, has the author and date on it, so that we can attribute it to who wrote it, and you can remind yourself of when you actually worked on this, and one or two sentences explaining the purpose. So, for example, this is what I might do for this particular data wrangling session when we get started. So I'll just call it data wrangling, the map ECR development program, and so on. The second tip is to use lots and lots and lots of comments. Use comments on any new commands. Think of it like you're explaining to someone to understand the code and why you made certain decisions. And almost 9 times out of 10, that someone ends up being future you. So you might come back to the code a year from now, 2 years from now, even 5 years from now, and try to understand why you coded something a certain way or why you made certain decisions that you did. And comments end up being really, really helpful to do that. So something like here, I might want to say what I'm trying to do. I'm trying to sum all the confirmed cases, or I'm trying to calculate the proportion of confirmed cases using confirmed divided by tested. The last one is to assign values to store information. I think from the results of the CAS survey that I saw, most of you were fully aware of what this does. So use this greater than sign and then a dash, which is the same as an equal sign in Python, to assign information to a variable name. So like this. Now, I didn't necessarily do anything wrong here, but I didn't follow one of the good practices tips. Does anyone want to shout out what it is or put it in the chat? All right. Well, the only one I didn't really follow is the comments, right? I could have added a comment here saying maybe why the meaning of life is 42 or what this edited routine data CSV is. For example, I'm reading malaria routine case data from Tanzania in 2020 or 2018. All right. So, in terms of the actual lesson objectives for today, we will go through following and using good practices when we're coding, as we have, and then exploring a new data set and cleaning that data to find answers to simple questions. So we'll mostly be using the datapply library and functions such as select, filter, mutate, group by, and summarize. Then at the very end, we'll go through how to use the pipes to make your code cleaner. Now, I just want to stop here because based on the last couple of sessions and the CAS surveys, there's also been a bit of a spectrum in terms of what users are comfortable with. So if you are comfortable with this, you're comfortable using all these functions, you don't think there's anything new here for you to learn, then we can make a breakout room for you. And I forgot, was it Praise or Christina that was going to jump in the breakout room? Yeah, and Nima's just sent a message. So please, Praise. Awesome. Thanks, Praise. So just react to Nima's message if you'd like to join the breakout room, and I'll give you a minute to do that. Otherwise, if this sounds like cool stuff to learn and to something that would be interesting for you, then please stay on here. Sorry, Gerson, were you hoping to be included in the breakout room or in this session? Okay. No worries. We'll get started then. If there is anyone else, I think Kaiser reacted to Nima's message. If there is anyone that wants to join the breakout room, perhaps just send Nima a message and she can add you to that breakout room as well. But we'll get started for everyone else that does want to stay in this session. All right. So this was our first activity, but also the pre-workshop task. So to create a new RStudio project called Data Wrangling and read in the edited routine data. So please react with either a thumbs up or a tick mark, or if you have done this, and a cross if not, and then we can either help you if you haven't done this, or we can give it another minute or two for people to do this. Thanks, Gerson. Annabelle's also done. David is done. Sylvian, Witness, Arsene, Babaloa, how did you guys find this? Have you been able to do that, or do you need some time to do that now, or do you want me to talk through it? Kaiser's done it too. Awesome. Okay, then we'll power on ahead. Witness, Arsene, Sylvian, if you have struggled with that, please just message Christina and let her know. But otherwise, I will also do the same. So I'll close this one. I have this data wrangling ECR project set up, and I'm going to open up a new script for today. So data wrangling session. And then I'm going to have my comment block. I'll give it a quick description and then my name. And today's date is the 25th May 2026. Alrighty. So there were a few different options in terms of reading this in. The first thing I'm going to do is I'm going to load the tidyverse library. Because this library is really fantastic. It has the whole tidyr, dataplier libraries, and so on. I think Reader is also one of them. So if you haven't done that, I invite you to do that now as well. This would be a great time to do it. And doing this allows me to use the read underscore CSV function. So first of all, I'm just going to make sure I run this. So I'll press Command and Return on Mac, and I think it's Shift and Return on PC. And then you can see here, it's loaded the library tidyverse, and there's all these core tidyverse packages. And now we're good. If you don't have the tidyverse package, you might need to do install that packages tidyverse, and then give that a couple of minutes. So now I can use the read CSV from tidyr, from reader, and I have to give it the right path. So here you can see I've stored my data in a folder called data. So I have here a slightly cleaned version of the data, but for today we'll start with the old version, so the edited routine data. So I just have to say we're in this working directory. We'll go to the data folder and read in the edited routine data.csv. Alrighty. Nope, it doesn't exist. Why not? All right, we get to do some real life debugging. So we'll do get working directory, and this will tell me exactly what working directory my laptop is currently sitting in. We are in the right directory, so it should hopefully be fine. I might not need to have this leading space. Yeah. Okay, so we are in the right working directory. So now I just need to say, go into the data directory and then find this CSV. And now we have data frame. First thing we might want to do is let's just check out what it looks like. So we can use the view function from that. Nima covered that in her introduction to R section, and we can have a quick look and scroll around. This is very much like Excel, this particular view. We can see everything in tabular form. If we didn't want to type in the view, we could also just click on it and go straight here again. All right, so that's the first part done. Any questions? Is everyone happy? you don't say anything, I'll assume you're happy. Alrighty, so we'll head back here and go through the next step. So as I mentioned, there are some really handy functions that when you first read in the data set, you can use to explore. So view is particularly useful in RStudio because it opens the data like a spreadsheet, like an Excel file, and you can scroll through and see what it's made up of. Head or tail are also very useful. They show you the top and the bottom of the data. So the head will show you the first 6 rows, and that's really useful just to get a bit of an idea for how the data might be distributed, what the different column names are. You can see that it tells us that there are more column names than it was able to print. And tail will do the same, but show us the bottom of the data. So here we can see the last 6 rows. Structure of the data frame will show us what the columns are made up of. So you can see that admin 1 is a character column, which has 1200 values, and the first few values are west, 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 and so on. Then we have some number columns, but pretty much this whole data set is either character or number. The last one, summary, is also not bad. It can show us sort of everything here from the minimum to the maximum, the median and the mean of a column, where it's a numeric column. If it's a character column, it doesn't really have much to give us. And then we can see as well with things like the year, test under 5, and so on. So we can see here that there are a few problems with the data. So there's a minimum year of 18, which doesn't really make sense. We'd probably expect that to be 2018. And the maximum of 3018, which also doesn't make sense. So there's a couple of things that we need to see here as we're looking through, just that we need to keep in mind that we need to edit in the data before we start to get statistics out of it. Something else that is problematic is we can see that the column names aren't quite consistent. So this one, for example, doesn't have underscores in the same way that all the other ones do. Whereas this one has capitals, whereas nothing else really has capitals, and this one just the first letter is capitalized. Normally, this doesn't mean that the data is wrong, that there's an error with it, but if we can get all the column names standardized, then we don't have to think about, oh, what was this exact specific column named? It will just follow a convention, and we can code quicker and more effectively. And the last one is class, which just tells us that it's a tibble, a data frame, and so on. So I'll keep all those here together. All right. You are welcome to try those yourself. Hopefully you've called your data something like DF just standing for data frame. Make sure that you get similar results to what I do. If you have something that looks wildly different, we might have read in different data sets. Okay, awesome. So the next step and the final workshop question, what we're trying to get to is, and what that colleague from the very first slide tapped us on the shoulder and asked was, what is the total confirmed cases of under 5-year-olds in April across every admin 1 zone in this data set? And R is going to be really helpful in getting that answer. So first of all, we might have seen in the data that there are a few NAs. We can very easily remove these using the na.omit function. Noting that if you prefer tidyverse and tidyr functions, you can also use drop na, and they do the exact same thing. So if I go back to here, let's remove all NAs, and I invite you to follow along for this one, and let me know if you get stuck. So we're just going to do df is na.omit df. Now, why do I assign it to a variable called data frame or to a variable called df? Because if I just do this and I do my command and return, then it prints to the terminal. It just sends a data frame with the NAs omitted to the terminal. But that isn't exactly what we want. We want our data frame to now not have any NAs. So we assign it to the same name as it was before, which just means we don't have to have like df1, df2, df3, but we can do that if we prefer. We just have to be careful with the renaming of variables. And later on, when I start talking about pipes, this will also help. So we can go ahead and execute this. And now we can see that our data frame has 1,178 rows, whereas before, if you remember, it had 1,200 rows. So we've removed 12 rows which had an NA value. And if you remember when we opened it, there was one here which had an NA somewhere. And we've just gone, you know what, to keep it as simple as possible, if there's an NA in the rows, I don't want to see it. I might just do a little stop here. Any questions on that so far? Everyone tracking along okay?
Yeah, can you give a thumb up? Can you give a thumb up if you're following?
Thanks, Christina.
Yeah, I ran code, but I didn't see the result. And I think that is not an error.
Yeah, so what exactly are you seeing, Gerson?
Okay, so I tried to meet and
Would you like to share your screen quickly and we can see if we can diagnose what's going on?
okay,
So you're executing this?
yes, but I didn't see the result.
Yeah. So you shouldn't see it in the sense of it shouldn't print to the terminal, because what it just did is it reassigned the data frame with all the NA values omitted to a data frame with the same name called df. So now if you run df in the terminal, then it would show you this. So can you see here how I have df na.omit brackets df? It doesn't print anything to the terminal. But then when I run
Okay.
df, then I can see that, yes, my new data frame now has 12 less rows in it than it did before, and there's no NAs anywhere. Do you want to see if doing that helps?
Okay, let me try.
No worries.
No, maybe because of configuration, I can see it later.
Sorry, you can see it now?
No, maybe I can see it later.
You can see it
'Cause
later.
I ran. Okay, let me share my screen
Sure.
so that I can see what. So I ran this code, and then the result can be. So I didn't see the output.
So I don't think you've read the data frame in. So you need to do the first part, which was df read CSV. So if you paste something like this in, up above the view df, so between the library tidyverse and the view df, so on line 4.
So can you said I have to what view df, that's it.
Yeah, yeah, right there. No. So type in what I've sent in the chat, or I can read it out to you. It's just the df and then that assignment operator. So yep, exactly. And then read underscore CSV.
Yeah, even see it in the environments already.
No. So you have the read CSV inside brackets, which is going to confuse it. So just delete those brackets. Yeah. And then instead of the point you have there, so delete the dot as well, and then open up brackets. So if you do a left bracket, yeah, and then quotation marks. So they're the little apostrophe type mark.
Um,
Yeah.
quotation mark is
On a Mac, it's like just to the left of your return uh, key. No, not the exclamation one. Like this one that's I've just put in the chat. Yeah, or that's also good.
okay.
That one's also fine. And then inside those quotation marks, though, you need to type in the name of your data or the file name. So it's edited underscore routine underscore data dot CSV. Yeah. No dot at the end. Perfect. And now if you do command run on that, then now you have a data frame. So see how it tells us that it's read something in now. So now if you run the view data frame, then it shows it in that tab. Perfect. Now you should be able to run the bit that was after that as well. Yeah, and it will remove all NAs. Perfect. Now, one
Okay.
other thing about your code. So your title, the data wrangling, needs to be in a comment. Otherwise, it's going to confuse R. So you just need to put a little hash key just before it. So on row 2, yeah, you just need to put a little hash there. Perfect. Yeah, that's fine to comment it out so that R doesn't try to run that. Awesome. How did everyone else go with that? Is that okay for everyone else? Arsena, you unmuted yourself before. Was that okay?
Okay for me, yeah.
Okay, awesome. All right, we'll keep going. I'll share my screen again. Okay. So, what we'll be using today is mainly the dataplier package. So the dataplier package is a really easy, really versatile package to use in R. Now, if you remember from, I think Naima covered this in her session, a package is effectively a collection of functions. So we load a package and then we can use all the functions that have been written within that package. It's kind of like thinking of it as all these different tools. Like this might be one kind of function, this might be another function, and so on. So we can install it as a dataplier library, or like we've already done via the tidyverse packages and the tidyverse suite. Tidyverse has really transformed R coding and data handling in the last few years. But if you're learning R for the first time, it won't really make a difference for you because you won't have to learn the old method. And dataplier is shorthand for a data plier. So a plier being one of these tools because you can sort of twist and wrangle your data in however many different ways with this package. So the main functions, and we'll go through them all in a little bit more detail, do one of two things. The first collection are all about manipulating the columns. So the select function helps us to only look at and to take on the specified columns from a data frame. The mutate function can create new columns, and we often do that using information from other columns. For example, we might say, give me a new column that is called column C that takes the values in column A and adds the values in column B to make this new column. Rename is all about renaming the existing columns to new names. So this is going to be really handy when we try to rename our column so that everything is consistent, like I was mentioning before. And clean names is around cleaning and standardizing the column names for consistency. Whoops. And filter is a really useful function for manipulating the rows. So this is around taking only the rows that meet a certain desired criteria. And we'll go through these all now in a little bit more detail. So the select function takes as its first argument the data, and then it's followed by logical tests for column names to be kept or removed. So as a very quick example, if you run select and then df being our data frame and admin1 being the, sorry, adm1 being the admin1 column, then all you'll get is one really long column. So you can see there, this is just the first 10 values of 1200 rows of admin1 entries. So it's like a new data frame, but just with this one column. So with this in mind, we're going to go back to Mentimeter. Hopefully you haven't closed it yet. And we're going to answer these couple of questions around what would the following functions do. So I'll go to the next slide. And you have three options here. If you've lost it, you can hopefully scan the QR code again or use that number. And I'll just give it a minute or two before I talk through it. All right. I might stop us there. If you're still getting it up, then feel free to have a vote. Great work. I probably tricked you guys a little bit because what I didn't tell you is that putting a minus sign in front of the column means don't select this column. So here, when I do select columns from the data frame df, I'm telling it to give me all the columns except for admin1 and all the columns except for admin2. So the right answer here is this middle one, where it's about returning a data frame with all the columns in it as per the original data frame, except for admin1 and admin2. If I didn't have these minus signs, like if these ones here were gone, then it would be this first one. Does that make sense? Any questions? All right, then you have another one to think about. What would this one do? So select data frame contains a string, so inside quotation mark, with conf in it. So there's three options. There's, will it return every row or column of df that contains a string with conf in it? Will it add, so prepend is like add to the start, conf to the start of every column name, or will it return every column that has conf in its name? And there's also a trick one here. So there's a trick answer and a right answer. So think about it carefully. All right, I think 6 is probably about enough. So yeah, I think some of you probably heard me say that it's a trick and went ahead and selected the right one. So absolutely, this returns every column that has conf in its name. So here we might like conf might be short for something like confirmed or confirmation or something like that. It doesn't really matter. Select will return the data frame with as long as the 4 letters CONF are found somewhere in the name of the column, but it will return the column. It doesn't care if there is a row that, for example, has conf in it. Like, for example, there might be the name of a city might start with conf, or it might say like conference down in one of them, in one of the row values. It won't return that column just because there is a row value that matches it. It'll just check the names. Oops. Okay, does that one make sense? Any questions on that? No? Awesome. So we'll head back into our PowerPoint.
Sorry,
Yeah,
can I go back? I have one
Mhm.
question.
Definitely. Go ahead.
So does it mean that, uh, for example, every column that has, I didn't get very well the difference between the first and the third one. Does
Yeah,
it mean
sure.
that on the third one, it's like when we have any name that contains conf will be displayed?
So it might be helpful to show you what I mean with an example. So let me just drag this onto here. So for example, here we might have name, we might have confirmed under 5, confirmed over 5, test under 5. And this might be our data frame. And then we might have someone named, um, like it might be the name of a city, and the city's named Conference for whatever reason. Perth, Dar es Salaam, and then we might have some numbers here. Now, if I were to read this data in, the difference, and sorry, it's really small, isn't it? Let me make it a bit bigger. The difference between selects df contains conf would be that this data set would return only these 2 columns, right? Because conf under 5 and conf under 5, these 4 strings, these 4 letters match this. It wouldn't return this one as well, which was what it was asking, because conference, we can see that this is a match, right, with these 4 letters, but it doesn't check whether these are a match. It doesn't care about the row values. It only cares about the column headers. So this would be the right one, and this wouldn't be right. Does that make a bit more sense, Gerson?
Yes, thank you.
Awesome. No worries. And contains isn't the only logical we can ask for. We can also use starts with or ends with. So, for example, we might use starts with like test instead of conf, or we might say ends with U5, so that then it gives us every column that is measuring something for an under 5 group. So there's a few different ones that we can use there. And just don't forget, we have to put the strings inside quotation marks. It doesn't matter if it's double quotation marks or single quotation marks, though. Now I'm just calling out another good practice tip, and this is a sort of, if you're really striving to become a great code writer and developer, I don't always follow this tip myself, but it is quite often that different functions from different packages might have the same name. You know, the developers of one package didn't talk to the developers of another package, and they just decided to call the function the same thing. So to make sure that this doesn't happen, you can specify the library you're calling from. So for example, we can do dataplier, select. And this will always use the select function from the dataplier package. Otherwise, if there's another select function from another package, it might try to use that select function without no, because it won't know which one you're referring to. So you can either do that. There's also ways of doing it where you specify, like if there is a conflict, then I always want to use the data from this one. But this is sort of a pie in the sky. It's if you can aim for that level of coding, then it's really nice. All right, we are going to do this one more activity before the break, which is all around cleaning column names. So we can inspect the column names with names, and I'll show this now. And then we can use the rename function to have the cleaned column name. So to have, sorry, the new column names instead of the old column names. And we're going to do that together. So first of all, I'll show what names does. And this is not a very descriptive column comment. So we'll look at column names, and then you can see here, it's printed out the column names of our data frame. So what I want you to do in the next activity, and we'll take sort of a few minutes to do this, and we'll probably roll that into the break as well, is to rename the column names that don't match. So here we have three. We have this one, the confirmed microscopy under 5, because there's a capital C. We have the capital letters of the test over 5. And we have this one, the test microscopy under 5, which doesn't have the underscore. So we're going to use the rename function to rename the columns. And the way that that is going to work is we're going to do rename of data frame, and then it's going to be new name is equal to old name. Now, the good thing about this one is that you can do multiple columns in the same function. So you can do new name 2 is equal to old name, and so on. So I'll leave that as an exercise. And maybe we'll also take a break. So let's come back at, what is your time? 12:06. So 7 minutes, hopefully a couple minutes to do the exercise and a 5-minute break. So 12:06, we'll get started again. I'll be around though if anyone wants to message me with any questions or anything. Thanks.
So anyone who was left behind? Okay, let me type.
Yes, sorry, Gerson. Here's the exercise again. No, maybe just give one more minute before starting to go through. As you guys are coming back, please do turn your camera on. It's always nice to see your faces, and we can sort of check in with how we have gone. All right, I might get started. Um, I'll share how I would do this, and then if anyone has run into trouble or can't follow along, then let me know and we can stop and debug. So first of all, I'm gonna make this a bit bigger. I hope everyone was able to see it up till now, but hopefully, if not, then this is a little bit better. All right, so I already typed in uh, this rename sort of syntax, and we know that there are 3 columns. So I'll even go one more and just do new name 3 is equal to old name 3. All right. Now the names I wanted to change were, let's see, what was the first old name? It was this one. So I'm just going to copy it with the quotation marks and paste it here. It was, second one was this one with the all capitals. So I'm just going to take it and paste it here. And then it was with the spaces, which I have lost. Ah, there it is. It's across the 2. All right. Now the new name is, to keep it consistent, I'm just going to name it exactly the same convention as all the other ones, but I'm going to turn this one into lowercase. This one should all be lowercase. So this should be test over 5, and this one should be with underscores in between. Test microscopy under 5. All right. So this should have done that. So we have df, it ran here, it renamed the data frame columns from this one to this one. But did it work? Well, we can just run the names data frame command again, and we can have a look. So this one now is lowercase, perfect. This one now is also all lowercase, perfect. And this one now has underscores in between. Awesome. Just before I ask how everyone went, what happens if I try to run this again? So what happens if I go here and I press command return again? It's going to give me an error. And it's going to tell me it's actually a pretty descriptive error. It's going to say can't rename columns that don't exist. And the first one, conf microscopy under 5, doesn't exist. Now, that is perfectly fine because now our data frame, our DF, has these column names. So we can't actually tell it, oh, take this old column name and change it to this. It's going to tell us, no, I can't do that because I don't have this column anymore. So it's going to give us an error, which is totally fine and exactly what we would expect. So how was that for everyone? Was that okay? Any questions? I think Christina said, but yeah, please do all react with a thumbs up if you're done. Raise your hand if you need to ask any questions. Awesome. Great work, Gerson. Alrighty. So we'll keep going and we'll move on to the filter function. So this function is no longer about the columns, it's about the rows. So this function lets us extract the rows from a data frame based on some logical criteria. So the first argument we pass to it is the data frame, and the second one is around the logical tests for the rows to be kept. So we're going to say like, if the value meets this condition, then keep it. And we can also say if the value doesn't meet this condition, then keep it or get rid of it. We can also use these to create more complex logic. So we can use an ampersand to say and, or we can use this big vertical line to say or. Now, what this does is you can give two conditions at once. Like, for example, I only want columns where the person's age is higher than 5 and they are malaria positive. Sorry, I only want to see those rows where the person is greater than 5 and malaria positive, as an example. So for example here, if we run filter on the data frame and the month is equal to Jan, you can see here that this row here has a column with a month equal to Jan, same with this row and same with this row. Then we are going to get an output, which is these three rows as our first three, and then again, any further rows, sorry, that have Jan in the month column are going to get added on as well. Now, there's a subtlety here where I've used two equal signs instead of just one. This is what we have to do in R when we're asking it, is it the same? We have to use two equal signs. If we give it just one, R might think we're trying to say that it's like an assignment variable and that Jan should be equal to month or month should be equal to Jan. But this is more of a question. We're saying, is it equal to? And every time that it is, it gives us a true, which is going to mean keep this row. And every time that it's not, it'll be a false. And we're going to avoid all these other rows. And yeah, that was just what I said. So we can also use this and to do two conditions, like I was saying earlier. So for example, we might want to filter to having the month of January and having confirmed cases under 5, which are greater than 200. So you can see here, this has only returned two rows. So from almost 1,1200 rows in the entire data frame, only two rows meet these conditions, with that having both the month is in January and a confirmed under 5 cases of greater than 200. And we can see here that the month is January for both of these rows, and confirmed under 5 is here, is 204 and 262. So there might be a whole host of different questions, so we can use filters to help us get closer to the answer. So that brings us to our next activity, which this time we're going to use filtering for a little bit of data cleaning. So for example, there should not be more confirmed cases than tests conducted. So we might want to choose to only include the rows in our data that have more tests than confirmed. What I mean is we want to filter the data so that conf under 5 is lower than test under 5 and conf over 5 is lower than test over 5. All right, so we'll give you 5 minutes to do that. Please do give us a reaction when you've completed it so that we know when we can move on. And if there's any questions, either pop them in the chat or take yourself off mute and let us know. Alrighty, how was that? Are we still working on it? Have people completed it? Just get you to give us a reaction if you have finished. Otherwise, I'll start explaining how to do it. Thanks, Sylviane. David, Witness, Annabelle, and Gerson. Are you still working on it, or do you want me to start chatting through it? All right. I might start chatting through it. And if any of this doesn't make sense, if you get stuck, just let us know. We also have Christina and Praise who can help us out as well. Oops, sorry, I didn't notice there was something in the chat. Ah, yeah, thanks. Okay, so we'll call this little section filtering. Now we have our data frame. We still have this 1,178 rows. But there are some rows here where the tests are higher than the confirmed. So let's just see if we can see one of those. Sorry, the confirmed is higher than the tests. And I think there was one not too far down. Maybe I'll have to look at it in view. Um, So test and confirmed. Yeah, here, this is a great example. So in West, in September, in Bamakiari, sorry, I'm not sure if I'm pronouncing that right. It says that there were 32 tested under fives, but there were confirmed cases of 68 under fives. That doesn't make sense, right? If we've only tested 32, how do we know that there are 68 confirmed cases? We can see here that it doesn't quite add up either, that there were 188 cases tested with RDT and 44 tested with microscopy. So we think that this number is probably wrong. But without maybe having access to the original data owner, we might want to, in this case, when we're trying to do just a simple thing, we might want to discard it. Later on, we might want to do more clever things, like maybe every time that this number is lower, maybe we want to update it to be a value from this column, so that if 32 is lower than 68, then actually we want to try and have it as, we want to update it to 188. But in this particular instance, we're just going to ignore all those rows. So what I'm going to do is I'm going to take the data frame and put it in a filter function. And I'm going to say, give me, so what did I ask for exactly? Conf under 5 has to be lower than test under 5, and conf over 5 has to be, whoops, lower than test over 5. And maybe I'll put this all on one row just for the sake of this one, because then we can more clearly use the and here. So here I'll use and it'll tell it to do to this test and this test, and to only return the rows where this matches. Maybe to make a start, I won't do this assignment, and I'll just do the filter, just so it prints to the terminal rather than assigns it to the data frame, and we can see what it gives. One other thing I'm going to change here is I don't want this to be strictly lower than, I want it to be lower than or equal to. For example, if there were 100 tested and 100 were confirmed positive, that is fine. That is useful information. So I want to be the confirmed number of cases to be either lower than or equal to the number of tested. So I'll do less than or equal to, and that's how we do it in R. And perfect, it's printed it out. So you can see now we only have 1,075 rows. So we're actually throwing away quite a bit of data here. And again, if we were doing this in the real world, that might be too much data to throw out. We threw out almost 100 rows of data. It's around 10% of the data. It might be too much to ignore. But in this case, we'll say that that is fine. So what I'm going to do is I'm going to assign the data frame now. And then now if I run this, I'll have my new data frame, which I can view in the terminal, or I can view in here, and it won't have that example anymore. So we won't be able to find another case where the confirmed number of cases is less than the tested number of cases. I will add a comment so that we don't forget what we did. We cannot have more confirmed cases than the number of tested, which explains why we made this decision. And then we are good. Now, if you remember all the way back when I was doing the summary of the data frame, there was actually one other quite weird thing. There was a negative 9,999 in the test under 5 column. Right? Now we can check if that oddity has gone away or if it's still there. So we can do summary of the data frame again. And we can see test under 5 now is lowest, at its lowest is 0, which is good. Nothing here is negative, nothing here is below 0, which means we're fine. Otherwise, we could have used filter again. So we could have said, I'll just say this, check this, there are no more negative values. Otherwise, we could have said, filter the data frame, and what column name was it? It was test under 5, I think. Test under 5 has to be greater than or equal to 0. And we could have assigned it to the data frame again. That is how we use the filtering. Any questions on that? Did that make sense? Thanks, witness. Was everyone able to replicate it and have their data frame? You should have your data frame come up to be something that looks very similar to mine. So it should also have 1,075 rows now and still the 17 columns. All right. If there's no other questions, we'll get back into the slides. The next function that we're going to talk about is the mutate function. This can either add new variables, so columns, to the data set or change existing ones. And here the syntax is we mutate and we enter the data first. So again, df, the data frame, and then we give it some new column name equal to some sort of function or some sort of operation. And we'll go back to Mentimeter. I think this might be our last Mentimeter question. Asking how would you create a variable of the proportion? Why isn't it? I think you have to type it in. A variable of the proportion of tested cases confirmed. Confirmed as RDT positive in under 5s. So how would you use the mutate function to create a new variable, which includes the proportion of tested cases confirmed RDT positive? Now, as a reminder, you might want to use columns like test RDT under 5 and maybe confirmed RDT under 5 would be handy ones. So I'll leave that there for a couple of minutes and we can start talking through the solutions. Anyone brave enough to put in the piece of pseudocode in there? And don't worry, this is anonymous, so even if you put something that is wildly wrong, I'll have no idea. If no one's feeling brave enough, just in the interest of time, maybe we'll move on because there's still a little bit more I want to cover before the end of the session. So, how would we create? Yeah, perfect. Divide confirmed under 5 by tested under 5. Exactly. And we just want to think about how to do this with our data frame. So we have the proportion of tested cases, confirmed RDT positives in under 5. So we'll go here. And we'll say this is an aside from the Mentimeter question, how to calculate proportion. And we'll use the proportion. We'll use the mutate function to do that. So here we'll do mutate. We'll feed in the data frame. And then we will say the proportion of under 5s is going to be equal to the confirmed proportion of under 5 by RDTs is going to be the number of confirmed RDTs under 5 divided by the number in test. Where is test? Test RDT under 5. And what this is going to do, I'll stretch this out a little bit so we can see the whole data frame. What this is going to do is for every single row, it's going to create a new column, which is going to calculate the confirmed cases divided by the confirmed cases by RDT divided by the test cases by RDT. So I'll do that here. Whoop, and I still can't quite see it. The data frame is a little bit too big. So I'll go the whole way across and I'll run that again. And here you can see the proportions. So I've created this new column where we've taken the confirmed RDT over 5 under 5 divided by the test RDT under 5. So here it's 201 divided by 279 is 0.72. 90 divided by 175 is 0.514. And if you're ever unsure, R is also a great calculator. So if you want to double check that what you did was right, we can just say, well, what is 201 divided by 279? It's 0.720. Perfect. And you can try a couple of those. This is just like a check, like a sense check if you wanted to be sure for yourself that what you did was right. Now note here how I didn't assign it to the data frame. I didn't use this. If I use this, then I would have this column now permanently saved, or not permanently saved, but in this working version of my data frame, it would be saved into that. But this was just an aside. I wanted to show how we would do it. So we don't assign it to our data frame. Any questions on that one? Did anyone feel brave enough in the end to, yeah, perfect. Conf under 5 divided by test under 5. Exactly. And you even used pipes here. The only thing I would say with this one is you didn't give the RDT. So if you remember, the question was RDT positive. So this needed to be conf RDT under 5 divided by test RDT under 5. But other than that, it's great. If these pipes don't make sense to anyone else who's reading it, I will cover it. Hopefully I get a bit of time. But effectively it passes the data frame as the very first argument. So instead of having df new column name is equal to the function, we pipe it through. And I'll explain that a little bit more in a bit. All right. So, yep, that is how you do it, and this is the extra column that we might see. We can also use the mutate function to help us with this data cleaning. So for example, you might have seen that sometimes admin1 is named central and with a capital C, and sometimes it's named lowercase central. Ah, yeah, sorry, Gerson, go on.
So now we use mutate to create a variable. Is it correct?
Yeah,
Okay.
but I didn't save this variable. So this variable or this new column, I printed it to the terminal because I executed this, but I didn't save it to my DF. So if I run DF again, you'll see I don't have this new column.
Okay.
Does that make sense?
Yes, thank you.
No worries. All right. So, yeah, these were a couple of the other problems we saw with the data earlier. So some of them are named central with a capital C and some with a lower C. And we saw that the year wasn't consistently entered as 2018. So what we're going to do is we're going to use mutate, and you can follow along with this one because case when complicates things a little bit more. And we will use mutate to update these two errors. So use mutate and case when to fix problems in the data. Whoops. All right. So we will first do it again without assignment just to check that what we're doing works. So we'll do mutate the data frame, and then we will overwrite admin1. So we take this column and we override it. So if we use the same column name, it will just overwrite what we had, and we'll say case when. Now this case when function is handy because as you can see here, it effectively asks if admin1 is lowercase c central, then we update it to uppercase C central. Then if it's none of these stuff, so true is if it doesn't meet any of these other cases, then we just give it the same name as it had before. So the value of the admin1 column, which is whatever it was before. So we can do that here. So we'll do case when admin1 is central, is lowercase central. Then with this little tilde, we rename it to uppercase C central. And if it's none of these things, so if it's true, then we name it admin1. This is the first one I want to rename, is my admin1 column. And the second one is I wanted to update the year. And the year should always be 2018. For this example, we'll pretend that we know that the data is always 2018, and that those 18, the year where it was written as 18 and the year where it was written as 3018 was a mistake. So we'll run this. Perfect. And we'll see now that it printed to the terminal. There were no errors. So we can assign this now and run it again. And now our data frame will have admin1 as all as capital C central. So there'll be no lowercase c. And every single year value will be 2018. And yeah, thanks, Nima, for calling that out. Make sure that the true is in all caps. Was everyone able to follow this one along and to do it themselves?
I found an error.
What did you find? You're muted, Gerson.
So I went to school. I don't know what happened. Wow.
Do you want to try and share the screen? Ah, sorry, you pasted it. Mutate, data frame, admin1. So you are close. There's a couple of problems there. So I'll just paste what you had here. So this is all fine. And then your admin1 is equal to case when. This bracket is facing the wrong way. So we're just going to turn it around the other way. So it's going to be when admin1 is equal to central. That's fine. But then you didn't enter this tilde. Now this tilde is just below your escape button if you're on Mac, and you have to use Shift and then this little tilde. I can also paste it in the chat so that you can use it correctly. But it should be like Shift and the button that's just below your escape button on Mac. And then we will say if it's that, then we assign it to central. And then you are also almost right here where if it's true, and we need to give it a space so that you can see how the colors changed. So it knows what true is. It is, we rename it. We give it the same name as it had before, which was admin1. Now the bracket, we can see that it highlights the brackets are all fine for case when, and then this bracket matches the mutate. So that should work fine. So this should be your updated code if you wanted to copy and paste it in.
So this is a result. I think that now is okay.
It's now okay?
I think so.
Awesome.
There's no error.
Perfect. And don't forget to assign it as well. So use the assignment to overwrite the data frame. All right. We have 20 minutes left. So I'll go over the last thing I wanted to cover. And then maybe before we do the activity, I'll throw it to you, Nima, for the mentorship overview. So the last couple of functions that we need to cover are all about summarizing the data. We can use the summarize function with the group by function to summarize the data according to different categories. So group by will first be used to instruct instruct R how to partition the data into smaller chunks. For example, if we group by month, then it would put all the rows that have the same month together, and whatever we ask it to then summarize, it will summarize across every row with the same month. So as an example here, we might want to rename our data frame to say we group the data frame by month, and then we summarize. So we take that grouped data frame and we want to know what the total confirmed under 5 cases per month is. And to do that is we sum everything that was in the confirmed under 5 column. And then you can see it here. So for the month of April, we might have 6,929 confirmed cases in total across the whole data set, but split by month. Does that make sense? Any questions on that one before I throw to an activity where you have to try and use that? All right. I'll share the activity. And maybe before we get stuck into it, just because it might run a little bit over time, I'll let Nima cover the mentorship program. So the next activity is going to be around creating a new data set. So using the data that you've cleaned that contains admin1, confirmed under 5 cases, and months, filtered to only the April confirmed cases. So there's a few different functions here that you have to think about. So containing admin1, confirmed under 5, and months. So you have to use the select function to select the right columns there. Filtered to only the April confirmed cases means we have to filter the month to April. And then we have to group them by the admin1 and summarize to find the sum of confirmed cases. And this will be the question that we started the session with, of what is the total confirmed cases of under 5s in April across the admin1 zones. And to do that, you can answer it in Mentimeter. So as a hint, it should be some value between 1,000 and 2,000. But before we get stuck into that, I will let Nima talk a little bit about the mentorship.
Yeah, thanks, Yuval. Yeah, so I have a quick update on the mentorship. You'll receive an introduction to your mentor sometime this week, which is exciting. So be on a lookout for an email from Poonam that will have that information. She'll also provide you with a resource, the Menti Guide, that just has information in terms of how to structure the relationship, how to prepare for that first call, just to make sure that you really make the most of this journey. And we ask that as soon as you are linked with your mentor, please do email them to set up a time to have that call with them. And before that, have a think in terms of what you like to gain out of this relationship, and what mentorship means to you. And then when you have that first discussion with them, have a chat about that with them. The mentors are probably very busy, and so are you. So you will have to take more initiative in making sure that you're guiding these relationships as well as setting up those calls. A few tips on do's and not to-dos. Again, be proactive in guiding the relationship. So when you have that first call with them, talk to them in terms of how frequently you want to meet, how long the check-ins should be, the preferred medium of communication, whether you want to be communicating via emails or WhatsApp, just to have a structure in terms of like how you'll be interacting with each other. Try to also have clear objectives in terms of what you are hoping to gain out of this journey, and make sure that your goals are realistic and achievable within the next 4 to 5 months. And just so that you're able to keep track of them throughout and making sure that you are getting the expected outcomes. Be curious. This is a great learning opportunity. So ask questions so that you can learn more from the experience of your mentor, and just try to make the most of this. A few tips on what not to do. So we don't expect a mentor to be your teacher. So don't ask them to look through your assignments or grade them. You can have them give you ideas in terms of things, but if their time doesn't allow, then you should also be mindful of that. We also ask that you respect the boundaries. So don't expect your mentor to always be available outside of the agreed upon time with them. But otherwise, we are really just hoping that this will be an opportunity for you to chat with your mentor about your career goals, aspirations, and when you start working on the independent projects, you can also receive a bit more guidance on that. But you can also talk to them about any other things beyond just this project. So we're really hoping that you'll be able to make the most of this, and do have a read at that Menti Guide. It's a really helpful resource in just like helping you get prepared and know how to structure and plan around these conversations. But also feel free to reach out at any point if either you don't hear from your mentor or just need a bit more guidance in starting these conversations. Yeah, so that's all the updates I had the mentorship. Another quick one was regarding the assignments. So thank you to everyone that completed that first set of assignment. Christina has started grading some of them. One feedback was, for the submission itself, we encourage you to upload instead of typing in the chat, just so that it's also easier for the teacher giving back the feedback. We can have a look at that because of the time. We can have a look at that in the next workshop session. Yeah, that's all. Yeah, Yuval, back to you.
Thanks, Nima. Yeah, great to hear. Excited for the mentorship component of the program. All right. Also, a quick thank you from me. There is the post-workshop survey up here as well, which I'm sure Nima will share after the class. But if you want to make a head start of it, the QR code is there. If you do have any questions about today's materials, data wrangling, R, modeling, statistics in general, please do let me know. This is my email here. And also, if you want more practice exercises or more courses, you can check out this data carpentry course, which has a lot of really similar stuff to what we covered today. You can see it's also the data plier package. And Nima, those slides, I believe, will be available, so you don't have to quickly write down all the links right now. There will also be homework, which is going to be very similar to what we did today. So you can see here, I've got clean it again if you need to. So a lot of the stuff we've done today was about cleaning it. And then the next two is again around grouping it and summarizing. So if you have done work today, please do save it because it will help you with the homework. But I'll put the activity back up. And again, as a reminder, you might want to use a few different functions, and then you can upload your answer into Mentimeter when you have it. I'll be here until the end of the session and for a few minutes after that, so feel free to stick around if you are working on it and close to getting the right answer. I'm happy to help with any questions. Thanks for paying attention and listening in.
Thank you.
Thanks, Annabelle. I also, just for completeness, I maybe with like 2 minutes to 6 in my on my time, 2 minutes to 1 p.m. I'll quickly go through the solution. So give it a go for 8 minutes or so, and then I can talk through the solution. Alrighty, I might chat us through this just in the last couple of minutes before everyone has to run off. So, let me I'll even paste in the description just so we can keep track of it as we are going along. All right. Final activity is to create a new data set using the data that we have cleaned. All right. So we'll call it DF final for final activity, and we will select from the data frame only the columns that we're after. So admin1, the column is named ADM1. Confirmed under 5 cases is conf on U5, and I can check that here, conf under 5. And months, so I'll have month here, and actually maybe I'll put month before it just for the ordering, just because it'll look a bit nicer. We can now see what the DF final looks like. Perfect. So it has all the admin ones by month and the confirmed under 5 cases. All right. Oh, by the way, did anyone put it in the Menti? No, no one had time to yet. That's fine. All right. Now we want to group these. Oh, and we want to filter them only to April. So we'll again assign to the DF final, we'll filter. And here we have to take the DF final, not the DF. Because if we take the DF, then it wouldn't give us a data frame with only these 3 columns. It'll give us the data frame we had from up here. So we feed in data frame final and we filter the month to only be April. And we can take another quick look. Perfect, only the April month, and we can see that sometimes there are multiple admin ones. Now, this is fine because the admin 2 here would have been different, right? There would be different administrative regions within the West province or within the West state. That would mean that this is why we have repeated entries. All right, so now we're going to group. So we'll do group by the data frame final. And what we want to group by is the admin 1. Not the month, the admin 1. And this will now be grouped, and then summarized will be a summarized version of the data frame final group. And what we want to do is we want to say what is the total number of confirmed cases in under 5 in each of these. So we're going to take the sum. So for this, it will say, okay, for every admin 1, which is West, we'll add 75 plus 88. And if there's any more in these 81 other columns, we'll add that to it as well. So we'll take the sum of the confirmed under 5. And then there we have it, the DF final summarize. If we take a quick look, will look something like this. So the answer for the most would be Central with 1,546 total cases. So I could go into Mentimeter and I would type in 1,546 and that would be my right answer. And if my boss asked me, I would say, hey boss, the most cases were in Central with 1,546 cases in the month of April. Done. Thank you very much for coming in and paying attention. Sorry, we are 1 minute over. We can probably stop it there. I'll upload this script as well as anything else. Like the slides, they'll be available online. Thanks again.
Thank you so much, Yuval. Yeah,
Thanks.
this is wonderful. Thank you.
Thanks, Annabelle. Just adding a couple of comments here. Thanks, Sylviane. Alrighty. Nima, we can probably stop the recording. Thanks, Gersten.
Yeah, sure. Could you also please check if it gets sent to you, either your account? Recorded?
I don't know where Zoom would send it to, but yeah, I can check.
Okay. Yeah, in the previous sessions, we did have challenges of it being stored in different places.
Oh, really? Oh, no.
Yeah.
Yeah, I can let you know if I can find it.
Yeah. Yeah, no worries. I think it gets processed. It takes a bit of time for it to get processed.
No worries. Do you... Oh, I'll go in and I'll update the announcement to go out. Are you planning to send that out today?
Oh yeah. And I'm gonna update the timing. So I usually send them out 1/2 the hour, so like 1:30. But I can go just like remove the timing so that whenever you're ready, you can just post it.
Okay. It's fine. I'll need a few minutes probably to upload the R script and everything. So no stress. We can wait till 1:30 to upload it.
Yeah. No, that's okay. Yeah, we can send it even later in the afternoon.
Okay, awesome. Thanks so much.
Yeah, thank you.
Thanks. I'm gonna drop off. Bye. Have a good one. Have a good rest of the day.
Bye. You too. Bye. Bye, Prince.
Bye.
Have a nice day.
You too.
Thanks.